Here, I introduced some of the real-time probe system and also real-time cyber system. In this year, I would like to concentrate on LAMP method. Previously, we tried to establish the method. What is the new point is influenza genome is a big diversity in gene pool. Sometimes difficult to identify broadly these strains. So we have to use the specific primer set to cover every strain. So after some struggle in research, we finally get some of the primer set. It is called population primer. The idea is if we can gene pool divided into several groups. Okay? So each group may be detected with each primer. When we prepare the primer set, all of them, and combine after mixing, it is useful for detection all of the genes registered in the gene bank. Okay, and then we have the system for the influenza H5, H7, and common type A common NPA LAMP test. Today, I would like to use 3 LAMP tests for influenza. Another is bovine diarrhea diseases. The virus is also genome varied in sequencing. Sometimes there are at least 3 serotypes. In each serotype, there are some variation in sequences. Also, it is difficult to detect broadly. Current PCR system sometimes miss the identification of the strain. Our LAMP method, using the same sample population primer set, useful for broad detection. Anyway, one is a subtyping H5H7 or other H subtype of influenza virus by one-step RT-PCR and one-step RT-LAMP. The second topic is broad detection of serotypes 1, 2, probably 3 serotypes of viral disease BVDB by also same reagent system. Okay, so please look at the textbook. The first page is, do you know the LAMP system? Have you ever used the system before in other diseases? LAMP system is very simple to do. Just add the genome itself into the reaction mixture and incubate, in our case, that's 40 minutes. Just 40 minutes is sufficient to detect the genome. The equipment for PCR or real-time PCR need temperature cycles program, but the LAMP is constant. Temperature is enough. So it is sometimes easier to detect the sample genome DNA or RNA. So you are not familiar with the LAMP test. I will show you briefly first about the LAMP test. LAMP is a constant temperature reaction system, and the most advantageous point is quick amplification. This is the amplification curve. This machine is small, but this is a real-time system. Okay, so we can see that the reaction result amplification plot quickly. The time is around 15 or 20 minutes. Incubation is sufficient. The machine can be portable, can be buried somewhere, and also there is no need for some specific care. For example, when we use the probe system, sometimes, how about your countries? Some person, only some specified person can use the real-time machine because handling is not easy. In this system, handling is very quick, very simple. If you have the tube, just add the purified RNA or DNA sample into the tube. After mixing, spin down, and start the incubation. That is probably today you can see the result in using the machine. Anyway, so 30 minutes. Within 30 minutes, we can see the clear amplification by real time. Okay, in our veterinary field, some virus is very wide, gene pool is very wide. Sometimes we don't know the real diversity in the sequences. So that is a very critical point to detect the viruses successfully. BVD is not covered by current published primer set. Influenza sometimes difficult before. Now we improve the system to detect all of the genes registered in the data bank. When we, for the influenza H5 virus, currently around 4,000 HAG are registered in the gene bank. Our system can cover all of them. It was expected by analyzing the sequence comparison of the field strain with primer sequences. LAMP is a quick system and simple and specific, sensitive, almost similar to the PCR or real-time PCR. So that's, the system does not require a specific well-trained person. So not specific lab training lab is not required. It's a good system for the screening test. Okay, if you influenza detection from wild bird, sometimes low frequent. So anytime you cannot bring the sample to the specified influenza diagnostic center. So you need to do some of the screening tests. Okay. In the BVD case, in your country, I don't know how it is important, but the virus spread to the heart. Sometimes mucosal disease often occur in some throat, in some heart. In that case, some brain samples should be treated, tested for the detection of BVD viruses. But usually the laboratory is just one. The person can handle the sample is very limited. In that case, we have this kind of the incubator. You can bring the machine to the field and it can be tested at the place. That's why this is a good screening system. Okay. Anyway, the quick amplification can be obtained. So, do you know the importance of influenza? Probably BVDB may be important also in your country, I guess. So, first practical is the subtyping of avian influenza. H5, H7 is important. We have to discriminate those influenza H5, H7 or others.
BPDV not zoonosis.
What?
BPDV not zoonosis.
Zoonosis?
No.
No.
So let me explain LAMP first to start the influenza test. This is some of the typical diagnosis system, probably in your country also. If we have some of the disease outbreak in the farm, samples should be bring to the some of the diagnostic center in your country. After it is positive, sometimes other institutions help for the final identification. This is a typical case of influenza. The human case-based system should be similar. In the hospital, our samples are tested type A or not, right? And then this is HA subtyping at the local laboratory. And finally, institution confirm the HA subtypes. This is a typical case. But if there are many outbreaks at the same time, the institution cannot handle at the same time. So delay of the diagnosis sometimes have permit the risk of the spread of influenza viruses. So human cases should be same. If we have in the future we have the new subtype of influenza pandemic, samples should be bring to the patient come to the hospital. But at the same time, seasonal influenza is there, so we cannot differentiate seasonal influenza with new pandemic. In that case, any sample should be tested for at the local laboratory. It would result in the panic of the many samples. Okay, and the institution should be safe. Cannot control the disease spread efficiently. Okay, in that case, if we add screening test in this system, it is better. Only the suspected case can be transferred to the diagnostic laboratory for confirmation. So there are two-way antigen detection system or origin detection system as a screening test. Antigen detection system is less sensitive, right? Sometimes we easily miss the identification that permits the spread of the infection, right? It is not good. So molecular system is better. We already have the PCR or real-time PCR, right? So when we use the LAMP test, if we can introduce the LAMP test as a screening test, if it is specific and sensitive and broadly reactive, the test should be useful, I guess, in the future. So when we compare, you are not familiar with the LAMP test. LAMP test is a genetic test for detection of the viruses. The broad coverage is the same currently. Okay, the rapidity is higher, and equipment expensive, or this is portable. We can connect the machine with our cellular phone to send the data, run file to the diagnostic center by phone, cellular phone. And also, this is only useful in the specified laboratory only because of that is very heavy, cannot move. This is easier, just less than 1 kilo, and 1 kilo. And that machine was used in Africa for Ebola diagnosis before at the time. We have the ever outbreak 3 years ago, 3 or 5 years ago, right? At the time, this kind of the machine was used for diagnosis. The information transfer, the result of the analysis data transfer directly to the center of the ministry to control efficiently. Okay, this system is sometimes useful in the veterinary field. So, okay. LAMP is a sensitive, rapid, and easy to handle genetic test. In spite of these advantages, narrow detection spectrum of the current LAMP test hinder its field application. So we overcome by using the primers called subpopulation primers to overcome the narrow spectrum of the LAMP test. Current today's LAMP test you are going to use is broadly reactive. This is the sum of the schema to explain how those genes can be amplified. It takes 2 pages. You can also see the application system in the internet. So if you are interested in you can follow the LAMP homepage. So because it is not clear to explain, sometimes confusing. There are some systems for detection of gene amplification using if a precipitation product can be produced. So some sensor can detect the precipitate, which means the amplification of the genes. This HLB is the sum of the I. When gene amplified, the color become blue from purple. Some reagent sensing with the UV system. Today I'm going to use this system, but the signal can be detected by machine itself. Okay. Sometimes LAMP tests developing with broad reactivity is not easy because PCR needs 3 primers, maybe easier for design. But LAMP needs 8 primers, 8 primers for 1 cell. The product size around 200. So when we imagine the different sequence variation in the 200 within 200 nucleotide, usually it is difficult to find out 8 conserved regions in the small area. And also we have to choose the subtype specific region when we develop the H5 specific or H7 specific. That's why developing the LAMP test was not succeeded before. We tried our system to design the primer. This is the different Excel sheet to show the different sequences. Sequence is very small, you cannot see anything on this screen. But the length of the nucleotide around 1.8 hundredths. And at the time, all registered in the gene bank, more than 2,000. 1, 2, 3, 4, something 2,000. Okay, each Excel cell contains 1 message. Okay, so there are some green bar contains each primer site, and also red bar contains forward 4' set, reverse 4' set, something like that. Okay. So when we see the count vertically, how many A adenine or guanine associativity is present in each nucleotide position? Okay. So we see that if all of the A is present at this, for example, this sequence position, this is the when we get the variation data throughout the entire genome, we can say which is the conserved region, right? When we found some of the conserved region here, and also we did, for example, this is the consensus sequence, which for all of the 2,000 genes. When we add the conserved region here, so and count how many mismatch are present in each strain, gene. So count mismatch number of the less than 2 is acceptable for gene application, but more than 3 cannot. In that case, when we use this primer here, so around half can be detectable, others are not. So we make another consensus sequence here, and that is a primer, another second primer, and we can count how many strains are detectable, and others are not. So we can make the third subpopulation to design a consensus sequence. It's such the third primer, like this way. Anyway, we can cover all of the genes. Okay, so we did every sequence position. That is the system we can design the primers. AGTC is here. Okay. The position number 405. So, for example, most of the gene, except for the one, is the G. Like this way, this is not those are conserved, but these are not conserved. So we see the more conserved region, and also design primer by subpopulation method. Okay, and move to the practical one is the subtyping H5, H7, or other subtypes. Okay, I briefly explain about this one. Okay, your file has some of the references here. Before the slide file, so you can see some of the reference. Okay, so the primer sequence, next page, you see the primer sequence of our LAMP test, H5, right? And also there are some virus strain used in our experiment. It means that the target gene we use in this experiment is followed. Okay. Influenza virus has also mixed virus. It contains the HAG, right? There are 16 subtypes. The important H5, H7, or can be detected broadly when we try to develop the system. Others 14 subtypes are not important when compared with the H5, H7. And also, NP is common among the type A influenza. So if we can detect these genes, it means this sample contains the avian influenza samples. And also, if we detect this or this, that is the 3 detections. LAMP test is sufficient in the veterinary field. Okay, so we developed H5, H7, and NP. The position we designed the primer is, this is the entire HAG. First half is the HA1, second half is the HA2. This is the HA subtype specific region. And this is a cleavage side to divide into two proteins. So it is required a step for replication in the cell. This is the conserved region of the HA, sometimes conserved among cell types. Our primer set designed like this in this position. Today's experiment, very simple. Okay, in your on the desk you have the ice box. There are some of the LAMP. Red marked one is the influenza stick, strip, which contains 84 layers. Okay. The reagent is already added, prepared already. What you need to do is just take 1 microliter sample to add some of the layers. And start the incubation. Or detection system H5, H7, NP, H5, H7, NP. There are no space, H5, H7 only. RNA
Do you
sample.
understand? Do you understand?
Okay, the RNA sample, you have the add 1 microliter each. Change the chips, okay, microchips. 1, 1, 1, that's 1, 1, 1. Okay, 30, and after mix the start the incubation. Okay, so this is the H5 strain. Expected result should be like this, right? This is the same. Change the chips. Expected result should be like this. So we would like to add the NP detection well, but there are no spared well. We cannot test. But preliminary experience shows it was detected by NP system. Okay, you need to believe us. So in general field, this information is sufficient. This is H5.
Simple for him.
We have your friend.
This is the strain is H5. This strain is H7.
Yeah? She knows.
This strain is others.
She knows. Seriously. She knows this. So, that's good.
Yaman, he's your student.
Yeah.
As a screening test, this is enough. Okay, you can bring the sample to the diagnostic center of influenza.
Yaman.
Right?
PhD
So
in here.
what after add the 1 microliter of RNA sample
On training.
and before that, I have to explain. The strip, okay, is specifically produced by the company. It has a cover, and also there's some stopper at the top of the and here. It's difficult to explain. Anyway, turn and to push, right? This is a normal tube, normal tube for PCR, but it has a lock system. When we push tightly, it was locked. There are some other bar, the chip, the head of the cap of pan in under the bar should be locked, cannot open again after the reaction because the LAMP most problematic is frequent occurrence of the contamination. Now the cap was covered, cap was set it halfway. You can open by hand, okay. And after adding the RNA sample, 1 microliter each, using the different chips, and after adding, push the cover tightly to make the sound. That means that the cap was locked. Okay, and after that you need to
Mixing your face.
mix it by hand. Okay. Why you don't use the pipetting? Pipetting sometimes induce the contamination problem very frequently. At first we didn't know where the source of the contamination. Finally, we found the pipette man itself inside of the pipette man should contain should be covered with the product. Pipette, strong pipetting sometimes catch the solution up to the cavity of the pipette man. PCR should be safe. If you have your friend has a contamination problem in the PCR, okay, sometimes hand mixing is easier. Can also is very effective way to prevent the contamination. Okay. Today we don't use a pipetting. Okay. Add a sample and push the cap until we hear the lock sound.
Okay.
Okay, and mixing by finger, yeah. And then we have the machine, centrifuge, microcentrifuge here, and add here, spin briefly, and mixing again by finger,
Okay.
2 times.
Before
And,
and after.
and start the incubation here. I am very sorry. Just 2 groups is acceptable for the reaction. Other sample cannot. Or if you stay more time, you can do that. Okay.
Only 2.
So
The lesson was written in the slide, and also in your textbook, you can see the precise way, precise method of the method. You see?
Method. What the meaning is that?
In my textbook, there are some
What the meaning
protocols.
is that?
In textbooks.
Contain.
In textbook.
No. Before.
I don't know what he means.
Okay, this is the influenza.
And see in textbook.
Okay,
Alright,
anyway,
something.
experiment is very simple. Add cap, lock,
Same.
and then mixing, spin, start incubation. That is
That's it.
Very simple, no need to consider. Okay.
Simple for him, not simple.
Using the usually we wear the gloves for molecular diagnostic test, right? You can take gloves, those gloves. If someone prepared just two groups can be add some group here. Okay. Do you have some question?